Okay, so welcome to this session on the Internet of Things, Architecture Made Simple. 9 key questions to ask yourselves to simplify your IoT solution. My name is David Goad. I'll introduce myself a little bit more fully in a second, but this is the session for this part of the conference. Okay, so what's the agenda that I'm going to cover? And I probably won't take the full 60 minutes, probably take about 45 with questions, but we'll go through this. I'm just going to do some brief introductions, talk a little bit about myself and what my background is, talk a little bit about what the Internet of Things is. I think I looked at the conference agenda and there weren't a lot of sessions on IoT, maybe 2 or 3. So I thought it'd be important just to do a little bit of a background and talk about why architecture is a challenge for the Internet of Things. Talk about some of the challenges associated with deploying IoT and some of the issues that people are trying to do to address those issues. And then I've come up with sort of 9 key questions to simplify your IoT deployment. So in effect, 9 questions that could be, the start of your tender, your request for tender, or some sort of specification document, which should allow you to simplify down to a select few solutions in terms of IoT and a select few different sets of technologies. So just to introduce myself, as I said, my name is David Goad. I'm the Chief Solution Architect for Automation Innovation Hub at the University of Sydney. I'm also what they refer to as a Microsoft Regional Director. I'm sure there's quite a few Microsoft RDs and MVPs at this conference. I have well over 25 years of experience in this space, and I teach Internet of Things, Artificial Intelligence, and Innovation at both the University of Sydney and the University of New South Wales. And I carry certifications in AI and IoT. And I used to run my own business. These days, I just do consulting and strategy, talk about IoT and AI, do a lot of master classes, help senior executives try to make sense of some of these more complex technologies. If you want to connect up with me, you can use that QR code there, which will link you to my LinkedIn. You can connect up with me on LinkedIn if you have any questions. So what is the IoT? And what I'm going to do is just talk a little bit about what IoT is. I have a little video that I'll play for you guys. If the audio doesn't play, then please let me know. A little 2-minute video, and then I'll just talk through some of the issues and challenges related to IoT, which will then set me up for these sort of 9 key questions related to IoT architecture, which I'll talk about later on in the session. So just a little video on what is the Internet of Things. Please let me know if you can't hear it. Oh, so the video is not playing. Okay, so we'll have to skip that and go to the next part. So, what is the Internet of Things? The Internet of Things is basically everyday devices connected to the Internet, providing us with highly useful information about us and the world around us. IoT is useful for a variety of reasons, not only the data it provides, but also the ability to sort of control our environment. And it's something that's here and now, and it's something that people are interacting with every day. So you have everything from smart cars to smart cities. The Australian government has dropped millions of dollars investment in terms of trying to improve cities and travel through cities, everything from smart garbage cans to smart parking spots. You have internet connected cows. People are basically connecting sensors up to livestock to be able to tell the health of the livestock, tell where they are, make sure everything is okay with them, which you might think is funny, but for a cattle herder, a cow is a $2,000 to $3,000 asset. If the cow, more often than not, particularly in Australia, the only time they know that the cow is sick is when they see it dead out in the paddock. So having some sort of telemetry on the cow to actually tell when it's sick is quite useful. Internet-connected pacemakers, very common these days. When people get installed in a pacemaker, they'll have a little Bluetooth station at their house, and as they walk by the base station, that it will collect data about the person's pacemaker and allow the physician to make adjustments for that person's pacemaker. You have internet-connected fridges now. All kinds of building telemetry, drones, and internet-connected lights. It's expected by 2021 there will be about 25 billion things connected to the internet, which will be probably 3 to 5 times the number of people connected through the internet. So these are just everyday devices. I could quote you other statistics. They figure that in the average Australian home within the next 2 to 3 years, there'll be close to 60 to 70 devices connected to the internet, everything from smart TVs to smart cameras to smart speakers, the ability for people to turn lights on and off and various devices on and off, all kinds of things. By some estimates, by 2030, there'll be over 500 billion devices connected to the internet. And as an industry, the IoT is expected to generate over $14 trillion in profit up to 2023. And it's expected that half of all IT deployments in the next 3 to 5 years will involve some form of IoT. So it's certainly the case that IoT is becoming a major part of IT or technology as we go forward. And let's face it, we're in a conference that's about big data, data management. The reality is IoT is the single biggest source of data. It surpassed social media as the primary source of data about 3 or 4 years ago. One of the reasons why, as a researcher, I study both IoT and artificial intelligence is it just sort of makes sense, right? Because the IoT feeds the data into the AI, which then we can do something useful with. And I'll talk a little later on in terms of one of the 9 key questions you have to think about is what is your strategy with relation to the Internet of Things and artificial intelligence, because there's different ways you can approach it as an organization. And by most people's accounts, IoT is one of the 4 critical technologies for the 4th industrial revolution. So they talk about cloud, they talk about IoT, they talk about artificial intelligence, and they talk about mobile. For those of you who are a study of history, right, the 1st industrial revolution depends on who whether you're a historian or not, and what you consider to be the landmarks. But the 1st industrial revolution was typically considered to be the steam engine. The second one was considered to be the electric light in the automobile. The third one was the internet. So most of us lived through that. And the 4th one is now these 4 technologies. What all these industrial revolutions have in common is that they fundamentally changed the way we live and work as individuals. The internet created all kinds of new business models for people, ways of doing business. It's clear with COVID that organizations now are heavily dependent on the internet in terms of services delivery. And you see all these other technologies every day, right? Artificial intelligence. I'm sure you guys have seen talked about this a lot in other sessions at the conference. There's examples of this every day. Everything from smart speakers, which is the smart speakers, your Google Home, Amazon Alexa, #1 selling consumer item last year. Mobile devices, you get a situation now where most people have 2 or 3 mobile devices. Most organizations have a component of their infrastructure in cloud. All these different technologies are enabling a lot of different things and changing the way people sort of live and work. And IoT is certainly one of them. So what are the 4 key challenges with IoT deployments? And why are these challenges? And I'll go through each in general, and then we'll drill down into this issue of architecture and why architecture is a challenge for IoT. So the first thing is business models. Just like the internet enabled a whole bunch of new business models, the IoT is also enabling new business models. I'll say this to you, that it's not necessarily the technology that creates the value, it's the business model that the technology enables that creates the value, right? Why is Google, why did Google as a search engine start out and make, billions and billions of dollars? Was it the actual search engine technology, or the fact that Google figured out a business model, which is they pay per click advertising, right? So just like with, the internet and previous technologies where the business model is absolutely critical, business models are absolutely critical with the Internet of Things. And you're seeing all kinds of new business models being enabled by the IoT, share bikes, share cars, people selling telemetry data around environment. I saw a presentation last week by an IoT startup that was selling instrumentation to be able to track noise pollution around building sites. So there's all kinds of different business models that are being created by the IoT. The challenge is that there's no clear business models that are sort of becoming the winners, and it will take some time for people to figure out what the best business model is for all of these different IoT style solutions. The second issue with regards to, or challenge with regards to IoT deployments, is security. I was at a presentation 2 years ago where the head of the University of Sydney Business School said that he felt that IoT was the single biggest threat to people's security in modern days. And the reason for that is very simple. Traditionally, if we were working on the internet and we had a security breach, what was the worst case scenario? We could have some financial impact. We could have identity theft. Now with IoT devices being connected to the internet, and with these devices, making decisions about us, everything from internet-connected cars to telemetry and elevators to all kinds of other things that these devices are managing for us, it is possible for people to hurt people through security breaches. So because the physical world is merging with the digital one, security now has gone up considerably as a concern related to the Internet of Things. And as I'll talk about in a minute, one of the challenges with IoT architecture is this issue of security, the fact that people are sacrificing, in some cases, security for cost. So we'll talk a little bit more about that in a few other slides. This issue of privacy. We're collecting all this data. As I said, the average home now has probably 60 or 70 devices in the home collecting data about individuals. We wander around with our mobile phones that track our location, track all the different activities that we're doing. People's privacy is being impinged upon. And so one of the challenges with IoT is to maintain people's privacy, this adds cost. And to comply with the various privacy regulations that are out there. And one of the challenges is, depending on the country that you're in, the privacy regulation can be quite different. There's this issue, of cost of supporting these privacy regulations when you're doing your IoT deployments. And finally, and the last thing that we'll talk about through most of the rest of this session is this issue of architectural heterogeneity or architectural complexity. The idea that, in the case of, in the case of common IT now, most people can count on maybe one or two hands the number of common platforms, IT vendors, technology types. By some accounts in the IoT, there's close to 500 different vendors for IoT platforms. There's literally hundreds of different technologies that are out there. This adds complexity. This makes it hard for people who are deploying IoT solutions to figure out how they're going to do that, and hence why this topic of conversation. And this kind of leads to, this is kind of a little chart that I've done up in my view of how the IoT economics works, right? So you have the Internet of Things, it creates benefits. Largely it's creating benefits by reducing real world to virtual world media breaks. So by connecting the real world to the virtual world, we can eliminate a lot of the manual handling, the manual data collection, and we can speed up the actual actions that people take, right? And what this leads to is either increased information, more volume, velocity, or variety. As I said, IoT is now the number one generator of big data, or it can reduce your information costs for collecting the same amount of information, right? So these are both good things, right? And these create direct organizational benefits in terms of the information provided, and indirect benefits in terms of enabling new business models and being able to do different things. And this, therefore, provides is something that gets contributed into your IoT investment decision. The challenge is on the other side, you have these barriers, the four barriers that I talked about, right? Architecture, the issues of, reliability, control, integration costs, security, prevention of breaches, remediation of those breaches, privacy, compliance to rules and regulations, the impact on brand if you don't comply to those rules and regulations, and then the business models, right? And these all increase the IoT solution costs. What this is meaning is that things like architecture, because it's adding to the cost, it's actually contributing to a negative economics in terms of IoT deployments, and it's causing organizations to question whether they're going to invest in the IoT. So for the IoT to be successful in the future, people are going to have to look at these issues of architecture, these issues of security, these issues of privacy, and these issues of business models, and come up with solutions for all of them before people are going to see broad-based adoption. And this is very much why, if you look at Gartner, they talk about the fact that IoT is in sort of the trough of disillusionment, and that's because of the fact that a lot of these technical challenges still haven't been fully addressed yet by any of the vendors, not just Microsoft or Google. And so there's a lot of challenges that are going on to try and fix this economic decision that people have to make around deploying these IoT solutions. And the other thing that I often, and when I'm talking to CIOs and coaching people on their IT strategy, as I said, one of the things I do at the University of New South Wales is I teach digital strategy, and I advise senior executives on their IT strategy. So one of the things I try to tell them and convince them of is the fact that IoT is not the same as IT. And therefore, they need to have a different perspective in terms of how they're managing this technology and a different governance. And I'll illustrate my point, right? The first, it costs a number of different capabilities. First point is cost strategy, right? Typically, in terms of IT, we all have our laptops, we all have our mobile phones. Largely speaking, we spend the same amount on our mobile phone and our laptop every few years, and we change them out every few years, right? And what happens is we spend the same for a mobile phone, but we get more capability, more memory, more storage, more camera, more this, more that, right? In the case of IoT, what's happening is the cost strategy is different. People are actually, as the technology is advancing, they're actually using it to take costs out. So it's much less about giving you more capabilities for the same price, and it's more about giving you a lower price for the same capabilities. And I'll come back to this in a minute, but this issue of trying to reduce cost in the IoT is what leads to a lot of the issues related to privacy and security and architectural heterogeneity, right? And the challenges we have with architecture. The other difference I would say between standard IoT and IoT is the maturity. Most of the IoT solutions out in the market right now are maybe about 5 or 10 years old. And you'll see this in a minute when I show you some of the standards according to the Gartner hype curves, but a lot of them are still quite a few years away from what they consider to be maturity. As I said, architectural heterogeneity, right? The fact that you have a lot of different technology solutions out there, it makes it more complex to integrate these systems together. By most analyst estimates, most organizations will have at least 2 or 3 different IoT platforms that they're using, and they'll have to hook them all together. As I said, there's, if you go and look at Gartner, they list 16 available IoT PaaS platforms. By some estimates, there's well over 400 or 500, depending on the industry. Have we lost the actual presentation?
No, we are running on.
Okay, just we lost, someone dropped off, sorry.
Yeah, so just made me host and Amit dropped off.
Okay, all right, I'll keep going. So I was talking about architectural heterogeneity, the fact that all these IoT platforms are a lot more complex. Physical location, traditionally most IT infrastructure would sit in your data center or in your office, these days in your home. Most IoT infrastructure is in very weird and wonderful places, everything from factory floors to out in the middle of the outback to in people's chests. And these are very hostile environments, which makes it more difficult to connect and manage these devices. Going back to what I previously said with regards to cost strategies, a lot of times because people are reducing costs, this means the compute capabilities of these devices are very limited, which also means that this sort of, and also the storage capabilities are also very limited, which means that this sort of typical patch and replace process that people would have in normal IT, where if there's a security vulnerability identified and we would release a software patch, becomes much more difficult in the IoT space. A lot of these IoT devices don't have the ability to do this sort of patch and update, which means that security flaws can be in place for quite a long period of time. There's a lot more different communications technologies, as I'll talk a little bit later on when I go through the 9 questions, which means that you have more options, but also means it's more difficult to figure out which one to consolidate on. Power supplies. Most of these IoT devices are what they refer to as resource constrained. So if you take, for example, a parking sensor that sits in a parking lot, right? More often than not, they're not actually going to hardwire that in because it's going to be too expensive. So they'll install it with some form of battery. They'll expect that sensor to sit there for 5, 10, 15 years without having to be replaced. So that means that these sensors have to be in situ for a long period of time with limited power capabilities. And so they have to have the ability to be able to draw very low power, which again contributes to the challenges we have around security, architecture, these kinds of things. And then the other aspect of this is, as I said, because you're connecting these devices to the physical world and then you're making decisions based on them and taking actions, there's a whole issue with regards to process management and how you're going to manage things. And so this is why I say a lot of organizations think that they can manage their IoT implementations the same way that they've been implementing their IT and managing their IT implementations. And I don't think they can. I think that there's a difference in terms of how they're managed, a difference in terms of governance, and there's a difference from an enterprise architecture perspective that needs to be considered. And so the real question I put out to all of you is that, do organizations have the right expertise in-house and the right governance in place to build these, IoT solutions? And the challenge, I said, one of the, when we talk about architectural heterogeneity is that IoT is complex. So this is the framework that's published by the IoT Association or IoT Alliance of Australia. So they're basically the main member body that governs and provides advice to the Australian government around IoT deployments. And so I'm a member of the association. I'm one of the co-chairs. You can see here that they have almost 10 different layers in terms of all the different technologies that you have to think about when deploying an IoT solution. This is much more complex than the sort of 6 or 7 layers that you would talk about when you're talking about the internet, right? You have everything from the IoT endpoint to the gateway, the connectivity in terms of the communications tool sets you're going to use, the connection management, how you're going to manage those connections, how you're going to manage the applications, how you're going to build a user interface so that a user can actually get useful information out, managing and servicing the users, and everything from the industry solutions and the service provider. So these things are complex. They're much more complex than a standard sort of IT deployment. And the problem that you've got is, and the issue is not only is it complex, but there are literally thousands of solutions available, and there isn't any consistent standards, which I'll talk about in a second. And the challenge that you have for most organizations is complexity equals risk equals no decision. And so you're seeing a lot, when I talk to a lot of organizations that get involved in IoT deployments and a lot of the startups and solution providers, they'll tell you that one of the challenges they have is getting organizations to move from doing the initial pilot to actually deploying the solution, because organizations often will do pilots to try and see if they can figure out the complexity. And when they can't address it and they see this risk, then risk for them means that they won't move ahead. And so there's a lot of IoT deployments that are either stalled or not happening because of this issue of complexity. And there are a lot of gaps in terms of the standards and protocols. Like I said, there's a lot of standards and protocols out there, but a recent survey by the Alliance for Internet of Things and Innovation in the EU identified some 16 different gaps in terms of standards and protocols for the IoT. So as I said, it's very sort of Wild West at the moment. There's a lot of confusion out there. It's getting better. There's consolidation going on in the market, and a lot of the bigger vendors are working on these issues, and peoples are working on these issues of standards and protocols. But given the current state of the market, the complexity that's going on, it is one of the impediments to why people are not moving ahead with their IoT solution deployments. And as I said, a lot of these standards are very immature, right? So you look at, this is the Gartner Hype Cycle for IoT standards and protocols as of June of this year. And you can see that most of them are either, on the peak of inflated expectations or in the trough of disillusionment. There's very few of the standards that have actually made themselves, to the sort of plateau of productivity where they're widely accepted, and where people are using them, effectively. And this is a challenge, right? Because a lot of times companies will say, well, wait a minute, which standard should I pick? Right? It becomes a real challenge, right? And so it really, at this point, we're lacking a lot of clear guidance in terms of architecting IoT solutions. And you add all this together, and by most estimates, more than half the cost of implementing an IoT solution is in the integration. And so for these solutions to get more broad-based adoption, for us to generate even more data to get into the big data that we're all using and we're all talking about at this conference, then we got to work on reducing these integration costs by addressing these architectural issues. So now I come to the meat of my presentation. How do you make IoT simple, right? So given all the challenges that I say with the IoT, and one of the challenges being architectural heterogeneity and the fact that it's very complex and there's a lot of components, how do you make this simple, right? Well, here's my attempt to try and make it simple based on my experience of deploying a lot of these different type solutions. And it's a very simple concept. Basically, you just break it down into its component parts and ask yourself a bunch of key questions. And based on those questions, you should be able to self-select down to a handful of different technologies and solution providers that you can use for your IoT solution, right? So, they always say, how do you eat an elephant? Well, one bite at a time, right? It's very much in this case, you basically do a series of questions and you break it down into component parts. And even for the non-IoT practitioners, even for the novices in industry, you should be able to get down based on those questions and then be able to filter out a lot of vendors who probably won't be appropriate, or a lot of technology providers or hardware providers or software providers that won't be appropriate, and get down to the few that you can start talking to see what kind of value they can add to your organization, right? So without further ado, let's talk about the 9 questions, right? So what are the 9 key questions to ask yourself to simplify your IoT solution, all right? Well, I'll just go through them in sequence. So the first question you have to ask yourself is, are your things going to be mobile or fixed? Okay, are they going to be sitting in one position for most of their usable life, or are they going to be moved around into different positions? And when I say mobile or fixed, I mean, mobile within the states of a specific country like Australia, or mobile across multiple different countries. And the reason why I say this is because what you're going to find is that depending on what country you operate in, there'll be slightly different standards, there'll be slightly different specifications in terms of bandwidth requirements. Some of the vendors will have more of a presence than others in terms of their capability set, in terms of their deployment, particularly for the telecommunications vendors. Some of the solutions, have a broader base of deployment in certain countries than others. So you really need to have a think about where your solution is going to be, whether it's going to be fixed, where it's going to be mobile. If it's going to be globally mobile, then what geographies is going to be operating through, because that will have a significant impact in terms of the technologies that you select and the types of technologies that you use. Question number 2 that you need to think about when you're figuring out your IoT solutions and trying to simplify your architecture, and that is, are you going to be controlling or just monitoring? So does the communication have to be 2-way, or can it just be 1-way? Are you simply collecting data, and then are you using some other sort of format to manage that data. An example of a really useful IoT solution for collecting data would be a lot of farmers in Australia are putting little IoT sensors on their wells. It used to be that they would have to send out farm hands to go around and check all their wells every month to make sure that the wells were open and they had water so that their livestock wouldn't die. Now you can put a little $200 sensor on it. There's no control required. All they're doing is just checking to see that there's moisture at the well. So that's an example of a very useful scenario where all you're doing is monitoring, right? Examples of controlling might be, for example, in a factory, right, where you're using some sort of process control to manage a process in the factory and you're using the sensors. It's important to understand whether you're going to be controlling or monitoring because it's going to determine that, whether it's going to be one-way or two-way communication. And bear in mind that two-way communication in the IoT context is not always the best solution, okay? Simply because two-way communication is more costly, takes more power, and is more expensive. So if you have a scenario where you're only monitoring, you're only collecting data, then it might make a lot better sense to actually have one-way communication where you're passing the information, however you're doing it, through some sort of radio frequency or whatever, in a single direction, as opposed to trying to build a two-way communication device, right? And the issue, that all being said, so, if you don't need two-way because you're not controlling, you're only monitoring, right? Then you're probably going to use one-way communication and build your device like that. Regardless, there are issues that you have to think about if you're going to have one-way communication versus two-way communication, right? So one-way communication, just monitoring; two-way communication, you're actually trying to control something, right, at that actual device, right? Because if you're using the solution for control, not only do you have to have different technology, but it also probably implies different frequency and bandwidth requirements and different types of technology that you might use. It also implies that if you're going to try and do control, that you're going to have higher security requirements. Because if you're actually physically, you have an actuator out in the field that's actually doing something, like opening a valve or moving something, you want to make sure you have that's secure so people can't hack into it and do nefarious things, right? Conversely, if your solution is only going single direction, where you're only monitoring, right, then what happens if you can't, so if you don't have that synchronous sort of communication where you can actually, or asynchronous, where you're getting that feedback loop so the device knows that you've actually received the signal, then how are you going to make sure that you actually collect that information that, because of communications issues or whatever, you don't lose useful data? So it requires a sort of a thought process in terms of design if you're actually going to pass the information one way and simply do monitoring. And as I said, if you're going to use this solution for monitoring, you need to make sure that you have resiliency and redundancy in terms of how it collects the data and how it passes the data through so you don't lose any of that data. All right, so those are the first two questions. Question number 3, are your things or devices going to be resource constrained? Okay. So as I said to you earlier on in the presentation, one of the, traditional mobile phones and laptops, you never had a problem with power, right? If you were low on battery, you plug it into your local power source, right? And most of these devices were only expected to last 2 or 3 years, okay? And before you'd update them. So you never had a problem with power, which means you could have lots of compute and storage, which means that if you had to do patch updates from a security perspective, that was always easy. You could push those out. And by the way, we're going to get another device probably in 2 or 3 years' time, and you probably had several devices. The problem with most IoT devices is statistically, on average, an IoT device can be expected to be out in the field between 10 and 15 years, right? And as a consequence of this, and a consequence of the fact that most of them are connected to remote locations or locations where it's too expensive to provide hard-powered or hard-cabled power supplies, they tend to be battery-powered. What that means is that they're resource constrained in terms of the total amount of power that you can supply to the device. What this then means is that a lot of the standard protocols and tools that you would use in IT to support an IT network simply are not good enough from an IoT perspective. So protocols like HTTP and TCP/IP are very resource intensive. They use a lot of power. And so as a consequence, you can't use those style of protocols when communicating with these IoT devices that are resource constrained, that are battery supported, and are sitting in some weird and wonderful location. So over the course of the last few years, people have come up with a series of protocols which are designed for resource constrained devices like MQTT, CoAP, AMQP, and UDP, which are designed to have lower power requirements to allow you to facilitate these battery-powered devices that will sit out in the field for a long period of time. So this issue of whether your device is going to be resource constrained or not, and as I said, you could have a physical device that's actually located quite near a power source, but because of the cost of actually physically connecting to the power source, you could end up making it battery operated. It has to do with the economics of the device. If you're going to have battery powered devices that are going to be power constrained, then therefore you're going to have to think about these other different types of protocols and tools and standards for connecting your devices and operating them to reduce power consumption. The fourth question that you have to ask yourself from an IoT architecture perspective is, will you have a constrained or unconstrained networks? Okay. Now, the issue here is that it's really the last kilometer of the network before the thing that can often be the most critical in terms of your IoT solution. Because some of these solutions, as I said, are located in some really weird places. They either, if it's a factory floor, there could be a lot of interference going on from motors, these kinds of things. Believe it or not, devices connected into the human body actually have a lot of interference as well, because we produce a lot of electrical signals. So you get, in terms of these weird and wonderful locations, you get difficulties in terms of communication, the high latency, and high potential for packet loss. So there's a lot of research that's going on right now referred to around the area of low-powered and lossy networks, and protocols and standards and tool sets to be able to handle that. And so there's research that people are doing in this. For example, the Internet and Engineering Task Force is doing work in this area. The point is, if you're going to deploy these devices into weird and wonderful locations, you need to make sure that you understand whether you're going to have one of these, what they refer to as low-powered and lossy networks. And then you have to design and use specifications that are appropriate to those areas. Question number 5, in terms of, will you have high volumes of data or low volumes of data? Okay. And this ties back to this issue of control versus monitoring. But, you have scenarios where, like, when I went back to that example of telling you about the monitor on wells for livestock in the Australian outback, they only have to send a signal once a day. So it's very low volumes of data, right? The well's open once a day, ping, right? In some cases, though, you have scenarios where you might be monitoring, but you're sending information almost real time to create a real-time chart of what's going on. And you may actually be controlling, right, which will actually be pushing a lot of data the other way as well. So depending on the volume of data that you have, whether high volumes or low volumes of data, is really going to push a lot of the conversation around, cloud versus edge computing versus what they refer to as the fog, right? And all these technologies around containerization. There is a general movement and a general trend to more edge computing. So when I explain this to business users, they kind of get a look on their face. They say, wait a minute, we moved to the cloud. Now we're coming back. Well, no, that's not the case, right? Edge computing is very much a different style of computing compared to classic cloud or the classic on-premise computing that we're using. But what edge computing is recognizing is that for certain scenarios where there is super large volumes of data, and it doesn't make sense to pass all that data to the cloud, right, then using some form of edge computing may be more appropriate. For example, at the University of Sydney, we've deployed some CCTV cameras to monitor labs, because we have hundreds of labs across the university where researchers are working on weird and wonderful things that are very hazardous, and often they're working by themselves. So we're putting in monitoring systems just to make sure the researchers are safe, right? And so those monitoring systems are using CCTV, which are passing the video feed, and then we're taking an action upon it. If we see that the researcher's fallen down or there's smoke or fire, we can raise an alarm. Now, given that it's streaming video, it doesn't make sense to pass all that to the cloud. So we deploy edge devices to, trap the information locally, to also make the decision locally. And when there's an event condition, then that gets passed to the cloud, and we have the application sitting in the cloud with the critical data, a little bit of footage or whatever, so people can make decisions, right? So that's an example of where edge computing, because of the volumes of data involved, is absolutely a critical component of the Internet of Things. That being said, edge computing doesn't necessarily apply to all solutions in the IoT, right? If you have that scenario where you have that sensor and it's only passing one small bit of data once a day, there's no reason why you couldn't necessarily connect that sensor to the cloud. So whilst edge computing is certainly one of the growth areas in terms of development of the IoT, and a lot of organizations are heavily investing in edge computing, you're going to find that it's only for specific applications, and you really have to think about where you're going to use an edge device and where you're not going to use an edge device, because obviously using edge does add costs, right? So it's something you have to think about. The other thing you really seriously have to think about is this concept of containerization, because with the advent of edge devices, it's becoming much more popular to containerize both the algorithms that you're using to actually monitor the data that you're getting from these things and take action upon them, but also so the machine learning algorithms and also the data collection, that kind of thing, is all done in a containerized fashion. So this issue of whether you're going to go pure cloud or you're going to go some form of hybrid, use some form of edge technology, and so using edge technology, also possibly employ some form of containerization or Kubernetes type clusters is certainly a good question to think about. And a lot of it's going to be driven by the volume of data. The other issue too is the other reason why organizations are moving more towards the edge is because this issue of resiliency or redundancy. So, if you're running a factory floor and you have devices on the factory floor and you're doing control, you can afford, and you're connected to the cloud, you can't afford for your production facilities to go down because you've lost your internet connection or you got a bad internet connection or whatever. So having edge devices also provide you with that degree of resiliency, for those kind of more critical applications. Question number 6, in terms of how to figure out develop your IoT architecture, will your IoT devices be communicating over long ranges or short ranges? And there's a lot of misconceptions and hype that goes on around this because there's so many different competing standards, right? And so this is just a few standards. There's probably lots that I've missed, right? People, talk about 5G changing the world. Certainly with 5G, it's going to have, open up a lot of opportunities from an IoT perspective, but it's also a power-hungry, costly technology. And so a lot of other vendors and a lot of other companies and various people working on this have come out with other standards, other tool sets that are that handle this issue of power consumption, which is largely tied to bandwidth consumption, right, and range. So depending on the range over which you're communicating and the amount of data that you're pushing and your issue with regards to power consumption, there may be a different standard or different technology that's more appropriate to use, okay? And what you have to be careful of is a lot of the vendors will push one technology over the other. They'll say, for example, NB-IoT is the way to go and forget about everything else. And that's not necessarily the case. You really have to drill down into what's the application, what's the range, what's the bandwidth, what the power requirements. And based out of that, you'll probably come up with 2 or 3 options that will be most appropriate for your solution, okay? And recognize that depending, you get all kinds of different options out there depending on the range, right? I mean, I'm sure that there'll be people talking at this conference about Sigfox and NB-IoT and LETM and LoRaWAN. And then you got the ultra short range technologies like BLE, Bluetooth Low Energy, Zigbee, Z-Wave. They all have their advantages and disadvantages. But the first place to start is, how far do you want to communicate? How what's your power consumption capabilities? How long does it have to be out in the field? Are you resource constrained from a battery perspective? And how much data are you actually pushing, right? That will help you narrow down to the most appropriate standard to use from your communication perspective to communicate to these devices. Question number 7, in terms of our IoT architecture that you need to think about, this is the issue of what I refer to as adoption versus adaption. And what I mean by that is this, that oftentimes when you're deploying an IoT-based solution, there are already systems in place, right? It could be the factory floor where you have some sort of programmable logical controllers they're using for local control. It could be a building management system where you have a building control system to control air temperature, these kinds of things. So you're often putting in these IoT systems on top of existing infrastructure that may be old, that may be serial, analog style connections. And so you have 2 choices. You can either adopt or adapt your technology. So adoption involves using existing connectivity by adding a gateway, which forms the interface between the Internet of Things and the devices using non-IP connectivity, right? So you're adapting the existing technology. Adoption involves a systematic replacement of all these things with IP-enabled sensors, controllers, and telemetry. Obviously, the latter is going to be more expensive than using existing systems, but the latter does provide you with better security systems, it's easier to actually secure your connections, and will provide you with better flexibility. So one of the things you're going to have a thought process of is, well, if I'm connecting these IoT devices and I've already got some existing infrastructure, do I try to reuse that existing infrastructure and connect to it, which will have its limitations? Or am I going to basically try and replace it with all the sort of new and latest kit that's available out there? So that's another sort of key question that people will go through. Question number 8, in terms of figuring out what your ideal IoT architecture is do you have a preference for proprietary or open source solutions? So this idea of open source has been around for a long time. You see it in software, you see it in a lot of different technologies that people talk about. And it's particularly been gaining popularity over the last 10 years. For example, a lot of the best sort of AI capabilities are through open source libraries, from what I've found. And so, it's this idea that open source, is basically people are referring to, they're providing pragmatic methodology that promotes the free distribution access to end product design and implementation. So people work together to develop these products and they make them available to other people for free, right? Some organizations prefer open source because it means they're not locked into one particular vendor from a technology perspective. Other organizations struggle with the concept of open source because essentially if it's open source, there's really no one organization on the hook for the quality of the capabilities of the solution, right? So there's no one throat to choke. There's no one vendor to go after if you have problems with the technology, right? And so the question you're going to have to ask yourself is, is open source for you? Because this concept of open source has certainly found its way into various technologies in the IoT space, for example, LoRaWAN, right? Conversely, you also have other technologies that are very proprietary, where the vendors don't give you any details about what they're doing. And they assume that from a security perspective that, they assume this security through obscurity, where because people don't understand their technology, it's therefore secure, which is not necessarily the case either. But it's an important question to ask yourselves, are you open source advocates? Is that something you want to go down, a path you want to go down from an architectural perspective? Or, do you want to do proprietary sets of technology? Is that more important? And the last question that you're going to have to ask yourself in terms of your IoT architecture to figure out what's the best architecture for you is, really where do you sit as an organization in terms of your IoT and AI maturity? And is a breadth strategy versus a depth strategy more appropriate? And what I mean by that is this. So this is a classic diagram that talks about your IoT and AI maturity, right? And it talks about the fact that organizations go through a very sort of logical progression in terms of deploying AI and IoT solutions, right? The first thing is they're collecting some data, so they're very reactive. Then they start collecting some information and providing some historical reports, some KPIs, so they get a bit of history. Then they improve that to provide some more real-time information, dashboards, streaming analytics, decision support. So the data is more real-time so you can make better decisions. Then they start thinking about, okay, well, am I going to put in some sort of artificial intelligence or machine learning, right? So they might do some scoring, some classification, some machine learning. So they might get predictive. They might sit there and say, okay, I got all this data. I'm going to predict something and say, this is what I think is going to happen and provide that information to the operators, the people using the tool sets for them to take action on. The next step is once that prediction gets so good, people might then start using that information to be prescriptive. In other words, actually recommend specific decisions, right? I'm collecting information about that person's heart pacemaker and I see that this data is doing this thing. Therefore, I'm going to recommend to the cardiologist that they should make these adjustments, right? This can often be times to be based on simulation. Then what happens is you get to the next stage where people get so they trust the prescriptions being made by the technology, this IoT-based technology that's hooked up to artificial intelligence, that they largely allow the system to operate autonomously, right? Physical automation, process automation. Now that's a logical sort of process that people go through. The question is, do you go through this process across the whole organization, right, at the same time, or do you pick specific areas and take it to the maximum logical conclusion as quickly as possible? So I refer to these as the breadth strategy versus the depth strategy, right? So breadth strategy says that I'm going to move the whole organization up in parallel, the whole plant floor, the whole, whatever processes we're going to use around the health management, we're going to bring them up all together. And we might go through these phases and we might not get to the stage 6, but we might say, you know what, we want to have some really good real-time reporting. What we want to have it across the whole organization, the whole plant floor, the whole farm, whatever, right? Or we might say that, you know what, of a whole farm or a whole plant floor or whatever it is, it's really this specific process, this specific area that's generating most of the costs and most of the benefits for the organization. So rather than bring up the whole place or the whole area, or the whole whatever you're going to define it as, together, maybe we focus on one area, but when we take it as far as we can to the depths of maturity. So we might pick one specific process and take it all the way to making an autonomous process, right? So organizations have this choice when deploying IoT and AI technologies of a breadth strategy, bringing up everything maybe more slowly, but at the same time, right, getting a complete view of what's going on, right? Or they might decide that they might pick one specific area, but then move through the curve very quickly to get the most benefits. And so this is sort of the ninth question you have to ask yourself in terms of developing an IoT architecture. Are you going to focusing on a depth strategy or breadth strategy? Because that, again, with all the other 8 questions, will influence what the best technology options are for you. So reviewing all these different technology options, these 9 questions, essentially becomes a shopping list, right? Um, Ideally, if you go through and answer all these questions and you have an understanding of each of the answers, this should narrow you down very quickly from these 500 or 600 different platforms, from these myriad of different communications technologies, from these myriad of different devices down to a select few, which you should be considering from an architectural perspective, right? And so I'll go through each of the questions again. Question number 1 is, are your things fixed versus mobile? If they are mobile, where are they going to be mobile? Because that will determine what the available technologies are, what the available standards are, right? Are you monitoring or controlling? Is your communication going to be one way or two way, right? If it's going to be two way, what kind of security issues do you need to address in terms of your architecture? Question number 3, will your devices be resource constrained, right? Are they going to be put into a scenario where they don't have a lot of power, and therefore you're going to have to use technologies and standards that are designed for resource constrained applications that consume a lot less power? The next question is, as I said, will your devices be network constrained because of their location? Is there going to be a lot of loss? There's going to be a lot of data loss. Are there going to be a lot of interference? How are you going to design them that way? Will you have high volumes or low volumes of data? That will again determine the different types of technologies you're going to use and what the architecture platform is going to be. Will your devices be communicating over long ranges or short ranges? Right? There's a completely different set of technologies if you're communicating over short range, for example, within a building, then compared to communicating over long range, like say sensors out in the middle of a farm. Do you prefer adoption versus adaptation strategy? Do you want to try and make use of existing resources that you have already had in place, or do you want to replace all those just to make it easier architecture to manage the solution? Do you prefer proprietary or open source? Both has advantages and disadvantages. Proprietary, obviously, you have one throat to choke in terms of vendors, but you're also locking yourself in and taking the risk that some of these standards may become obsolete. If you go down the open source side, there's these issues of control and risk, these kinds of things. And then sometimes you get vendors that maybe have a combination of both. And then as a breadth strategy or depth strategy more appropriate for your business or your organization or your application? Because if you have an understanding of that, then it will help you actually identify which technologies that are probably more appropriate. So that's it for my presentation. Like I said, about 45 minutes. Hopefully you found it informative. If you have any questions, as I said, you can contact me on LinkedIn. I have written a book around the Internet of Things from a director's perspective that you can go and have a look at, or you can just connect up with me on a QR code. So anyways, I'm happy to do any questions now if people have them.
Thanks, Goad. That was a wonderful presentation. I have a couple of questions from the platform, though. Looks like one of them may be already answered in your question number 5. What is the impact of tools like SQL Edge that can run analytics on the IoT devices on the adoption of IoT? I think they're asking if it drives adoption of IoT.
It can, as I said, a lot of people are moving to the edge devices now or edge computing because of this needs for resiliency or redundancy. So the ability to be able to do more analytics and more power on the edge, certainly for certain applications, is going to be helpful. It's not necessarily a requirement for all applications. Obviously, if you have a few sensors out in the middle of a farm, you're probably not going to use a lot of edge computing there. But certainly for certain applications, factory floor, industrial IoT, these kinds of things, it can certainly be helpful. And I think
Cool.
there's another question about, are there other solutions like SQL Edge that
Yeah.
can reduce integration challenges? Yeah, I mean, I think all the vendors, including Microsoft, are trying to develop standards. I mean, for example, Microsoft now is going through this process of doing certified for Microsoft for all the hardware. And what that means is that if you're using a hardware device that's been certified for Microsoft, then it should work better with tools like SQL Edge and other Microsoft technologies. So the people are working on these issues to try and make some sort of consistency. The challenge that you have right now, whether it's a hardware provider or software provider or platform provider, is really worrying about, there is consolidation going on in the market. There's a lot of bigger players buying smaller players and pulling up the technology. So the question you're going to have to ask yourself is, will those technologies be there in 5 to 10 years time? Because I think there's a lot of consolidation that needs to go on because there's simply too many solutions out there in the market. Part of the challenge is that most countries, have been very slow to try to put in any kind of regulations or guidelines. For example, the IoT Association in Australia, we've been pushing the Australian government to try and come up with some more guidelines, at least around things like security and privacy. and they're slowly doing it. But it's like anything that's technologically complex, governments want to stray away from it. The other issue is if you adopt a standard, you're necessarily taking a view in the market. So in other words, you're saying, I'm going to prefer these vendors who are using this standard over these vendors who are not. And so I think a lot of times people are avoiding grabbing those standards because of this issue, or governments are avoiding regulating and forcing certain standards because it may disadvantage a certain vendor or another. But then what that does is it leaves customers in a quandary of, well, what do I pick, right? Is it going to be around in 5 or 10 years time? Sorry, a very long answer to a short question.
All right, thanks, God. I have a question actually. I'm also based in Australia. I'm from Melbourne. So, like, who would you can you recommend like a good vendors in the IoT space within Melbourne and Australia region?
I like I said, you have to in order. So you'd have to go back and those 9 questions, give me
Hmm.
answers to those 9 questions. And if you gave me
And
answers
then,
to those 9 questions, then I could point you to the 2, 3. And it depends what you mean by vendor: hardware vendor, platform vendor, software
all
vendor. These
right.
kinds of.
Let me put it this way. Do you have any consultants who can do the workshop around those questions and help me identify
Yeah,
um,
absolutely.
what my
I know
requirements are?
people who can certainly, because I work in the IoT Association.
Mhm.
Um, I know lots of both small consultancies, one-man bands who do this kind of architecture selection, and then
Cool.
I also know bigger people as well. So yeah, if you contact me afterwards, I can put you through to people.
Sure. Yeah, I'm moving into facilities management soon, and then I would have some requirements like that. But I'll get in touch with you. Thanks, God.
Sure.
So thank you everyone for attending. It was a great session, God. And if we have any other questions, I'll direct them to you. But otherwise, this is a good session. Thank you, everyone.